Hello everyone, welcome to your favorite channel AI Coding with K. I'm your host Kshitij Agarwal. I'm an engineering consultant and I help startups build AI products using AI. So this is a series that we're talking about how to help junior developers be more comfortable with AI, using AI to build products and really understanding an effective AI workflow. So let's get right into the episode. Cool. So this is episode 5 in our course, and in this episode we will be talking about how do you debug your code base with the assistance of AI. Okay, in the previous episode we talked about how do you control the implementation that the AI is doing using a phased implementation plan which has a tracker inside it. And in this episode we are talking about, okay, the implementation is done, the feature is built, but is it working properly? Is everything working fine? Okay, having AI do the development doesn't mean it is not going to have bugs. Like any kind of development, all code introduces bugs, especially AI, because AI does not have that level of experience of a senior developer, and even a senior developer like me would introduce bugs. So how do you debug your code base? How do you debug the feature that you just built using AI? Figure out what the problem is and how do we eliminate the issues, and how do we go forward, mitigate such issues that come. Okay, so one thing to note, and this is more of a definition kind of thing, failure is just a matter of you getting to know that something is wrong. Okay, a failure doesn't tell you what is going wrong. Inherently, you can conclude why the failure is happening, but the failure itself means that something is going wrong. And the definition of debugging is the process of finding out where the failure happened, why is it happening, and how do we fix that. Okay, this is the definition of debugging. Failure tells you something is wrong. Debugging tells you where it is wrong, where the failure is happening. Okay, so in our existing example that we are taking, in all of our previous episodes, the task tracker. So an expected behavior would be the task is due today, but what is happening, the actual behavior right now is that it says overdue. Okay, now the question is, what is the cause of this abnormality? Okay, the actual is not meeting the expectation, that is a failure. Where is it happening? That is the debugging process that we are going to go ahead and explore and learn how we are going to do it. So, important thing, guessing the cause of the failure too early is going to be even more detrimental to your feature, the implementation that you just did. Okay, if you know something is immediately you are aware that something is going wrong, great, that's fine. That means you have the awareness of what is happening exactly inside the code. But when we are working with AI, okay, there are still places where we have a blind spot, where we are not really aware, and we might end up making guesses of the issue might be in the task.kt file or in the view model or in the UI. So once you start making those assumptions or you start guessing and you start to fix the guesses prematurely without verification, that is where you start introducing even more bugs than what we had earlier. So a guessing loop is, there's a failure, you guess something, you tell AI to fix it, and you actually end up changing things which were already working fine, or you end up creating more issues in your existing code base. Okay, what needs to happen is that you need to have an evidence loop where a failure happens, you capture where the failure actually happened. Either you have logs, or you're using some sort of a debugging tool, or your tests fail. Okay, you capture that evidence of where the failure actually happened, and then you go into the code base, you look at the cause. Okay, this is where it happened, this is what is happening, and then you go ahead and go do the fix for that failure. Okay, so you need to give AI the exact, again, the context, the information that it needs to fix the failure. Okay, you need to tell it what is the expected behavior, what is actually happening, how do you reproduce it, what was the recent change. Okay, you can tell it to do a git diff, or maybe you already committed the code use, so maybe you can tell, okay, check this commit and see the changes that happened. This is the expected behavior, this is what is happening, these are the steps that I did to reproduce the problem. Okay, it could be a UI related bug, maybe you click on a button and it changes the state of the task without actually, which is not the expected behavior. So you tell AI, okay, this is the steps I followed and this is why what is happening. Okay, and you can also tell AI what you already checked and omitted as the probable cause of the issue, because then AI will know, okay, the developer has already checked this area and this is not the place to look for this issue. Okay, you can, the more, again, I'm again going to mention the same thing that we talked about in 2 episodes prior to this, where you give as much useful information, as much useful context to the AI to reduce the amount of guesswork and increase the accuracy of where the AI should focus. So for the failure, what should have happened, what is happening, what are the steps to reproduce it, where was the recent change you feel the issue might have been introduced. Okay, what have you already checked. Okay, now the very important thing to note here is, don't tell AI there is a failure happening, fix this. Don't tell AI to do that. Now it is going to open a can of worms for you. You tell AI there's a bug, fix it. What is the bug? AI doesn't know. Where is the bug? AI doesn't know. What is the expected behavior? AI doesn't know. Okay, what is it that it should look at for the failure? AI doesn't know. So all of these does not knows. AI will start making assumptions, start spending unnecessary time, tokens, and really just running about the code base trying to figure out, okay, the user said there is some issue, I need to fix it, but what? Now it's going to be very difficult thing for AI to figure out, and more often than not, it will never find the actual issue that is happening, and it will end up messing up your code base even more than you were expecting. Okay, so what you need to do is, like I mentioned in the previous slide, you need to tell, and one important thing is, even if you don't know the cause, you can ask AI to figure out the cause for you by giving it the relevant information. You can tell the expected behavior, the actual behavior, the code piece of change that might have introduced the error, what you have checked, what are the reproduction steps. If you tell these things to AI and then ask AI what are the possible causes of this issue, okay, so basically you're working with AI, you give AI the context of what is happening, and then you can ask AI, please suggest what are the possible causes. Okay, so for example, in this scenario, the AI might come up and say that either there is a timestamp versus date issue, or the today label is wrong, the copy is wrong, okay, or the UI has an incorrect value, which is why it is showing the incorrect label. So there could be a UI level issue, or a backend level issue, or a view model related issue, business logic related issue. So these are the possible causes that you figure out with the help of AI, and then you verify what is the actual root cause. So you have 3 suggestions. You also figure out where this could actually happening. Okay, so check one likely cause before you change the code. You figure out, verify, okay, this is where the issue might be happening. Okay, now you tell AI this is the possible cause, investigate further and verify if this is the actual cause. You confirm if this is why the failure is happening, and then and that is where you are ready to actually fix the issue. Okay, so in this example we are talking about having a test case do the verification for you. Okay, so you had 3 possible causes. So one way to do it is that you review the code. Okay, you ask AI to help you investigate those 3 possible causes, and the third very concrete way to do it, you write test cases for those possible causes. Okay, test cases are easier to manage, they are easier to verify, and if the test cases you add are failing in one of those possible regions, and maybe more than one, so if those test cases are failing, that is where you can confirm, very confidently say, this is the cause of the issue, this is where I need to fix the problem. Okay, so this is a prompt where you tell AI what is happening, this is where and you know exactly after running that test case that okay, the comparison is where it is failing, it is happening at the view model level. Don't change the UI, don't change the database, just focus on resolving the issue in this specific location. So in this case, the issue was at the view model level. You change the when loop, and you have resolved your issue. Okay, very important. Once again, if you fix something, if you change something, verify everything once again. I repeat, verify everything once again. A fix of a bug doesn't mean that you did not break something which was previously working. So you have to verify what was working earlier is still working now after that fix was made. Okay, so this is what unit test cases are for, this is what end-to-end test cases are for, this is what UI testing is for. You keep verifying things that are working should remain working after every change. They shouldn't break. So all your inputs, all your expectations, all your behaviors should pass. So do not introduce, or rather you verify whether that you are not introducing new bugs while you are fixing one bug. Okay, and a general practice, and especially when doing debugging with AI, is that you have to be careful not to increase the blast radius of the change unnecessarily that you are trying to, for the failure that you are trying to fix. Okay, you are not rewriting the whole feature just because there is one bug or there are numerous bugs and you can't figure it out, so you tell AI to rewrite the whole feature. That's not going to work. Okay, maybe you add some libraries out of so this happens a lot when you're working with third-party libraries, that you if you find a bug, you end up upgrading or degrading the library version just to check whether the bug is in the library or not. But it could highly be likely that the library is fine, there is no issue with the library, it is the implementation that you did with the library was where the actual issue came in. One important thing is verify whether your UI is not trying to hide a bug. Okay, maybe you made an incorrect, added an incorrect logic in your view model in your business logic side, and your UI side is also matching that incorrect logic just to show the correct answer. So at hindsight, things are working fine, but an incorrect logic in the backend matching, and you are kind of reversing that same incorrect logic on the UI, and it might seem that everything is working correctly, but it's not necessary. So do ensure that your UI is not hiding your bugs. Okay, and removing a failing test is something I've seen in my experience happen a lot, where developers would just remove a test case because it is failing, not fixing the test case or not fixing the business logic. Okay, so there are two things. A, your test case is failing because your business logic is wrong, or B, your test case is failing because it does not match the expectation of the change. So in both the cases, or rather in the first case, when the test case is failing because of the business logic, so you need to fix the business logic, and if the test case is failing because it is not matching the business logic, you need to update the test case, not remove it just because it is not matching the business logic or there is some issue in the. So focus on having your test case as it is, but ensuring that it is working fine by either updating the test case, adding new test case, or fixing the actual cause, or the whole debugging is that we are trying to do is for that scene only. Okay, so it is that. So a reusable resource that I want to share is you capture the debugging history. Okay, and this is for the long term when you're working on a big project, you're working in the team, you capture the history where you basically follow this loop. What failed? Why did it fail? What is the evidence of it failing? Basically, this means is expected behavior versus actual behavior. Okay, where do we check it? What are the possible causes, and how do we verify the location of the fix? By adding test cases, running manual test cases, reviewing your code. So you understand, you check, you verify, and then you fix. Actually, this is incorrect. You first verify the location of the cause of the issue, and then you fix the issue, and then of course you have to verify everything again because you want to ensure that you haven't broken any of the existing features. So we are almost towards the end of the session, a pretty small session today, and yeah, I've pretty much covered what I wanted to cover. Here is an illustration of how the debugging process looks like. So you observe the failure, you understand the failure, okay, you find the possible causes, you confirm the cause by code reviews, test cases, manual testing, whatever way you think. You ask AI for possible places where the issue might be happening. Okay, you make the fix, and then you verify everything again. Okay, So this is a standard debugging process regardless of which technology you're using, whether you are on Android development or not, or you are on iOS, or you're doing backend work, or you're doing web development. This is a very standard industry practice of how debugging is done, and how you can use AI to do your debugging, where you tell AI all the information of what is happening, you ask for possible causes, you write the test cases, or you ask AI to write the test case, failing test cases based on the actual behavior, and then you fix the issue and then run all the test cases again, verify if everything is working fine. Okay, so you do this cycle again and again until all your test cases pass, all the behavior, the match, the expected and the actuals match, and you keep working on this in a endless loop while you build your feature. So this is the end of the stream today. Thank you so much for joining in. In the next episode, we are going to be talking about how do you wrote the code, you fixed your issues. Now it is time for you to review your code. Even though you reviewed your code a little bit during the implementation phase, now we are talking about a deep code review, and how do you ensure that the code that is written is the way it should have been written. We're going to talk about it in more detail in the next episode. Thank you so much for joining. If you like this episode and if you think you have learned something, I would really encourage you to subscribe this channel, and that really is the biggest encouragement. It is still a very, very new channel, and your subscriptions and your likes are going to be very, very helpful. If you have any questions, if you have any comments, and if you want to share your own experiences, you can write in the comment below, or you can join my Discord. The links are in the description below as well. And yeah, I'll see you around. See you in the next stream. Take care. Bye bye.